partial fractions are a really useful tool in C4, particularly when you come to integration. But to do partial fractions, you've got to have a few ingredients. And the first one is a proper fraction. So this means that the degree of the numerator has to be less than the degree of the denominator. So for instance, if we've got x squared and a quadratic on the top of our fraction, we've then got to have a cubic or a quartic or something on the bottom. But that degree, that 2 there, has to be smaller than that 3 there. So it's got to look like a proper fraction in the sense that if we had numbers there, you would have a smaller number on the top and a larger number on the bottom. But here, obviously, we're using algebra, so we need a higher degree on the bottom than we do on the top. The second thing we need is a denominator with either linear factors repeated, or quadratic factors. So you need to just have factors like the ones I'm just writing down here, things like x minus 1, x plus 2. So there's linear, obviously, the degree of that expression there is just 1, it's just x. Of course, you could have x minus 1 squared. That would be okay, because you could write that bracket out twice, so it would be x minus 1, x minus 1. Or you've got expressions such as this on the bottom, so quadratic expressions. So in this example, what we're aiming to do is get the equation into the form two separate fractions rather. So one is 1 minus x and the other is 1 minus x squared, 1 plus x squared. So trying to think about what we would do if we were presented with the information in blue and we wanted to get back to the information in black. So we would have some kind of expression like this. Two fractions we're adding together. What we do when we're adding fractions, obviously, is we're trying to find a common denominator. So we would put our two expressions on the bottom of our fraction together, multiplied like so. And then this first one, whatever's on the top, we would multiply by the second fraction, because that's what returns our current fraction here to a over 1 minus x. And then to our second fraction, we would multiply it by the denominator of the first. So I've skipped out a step here. Rather than putting both a over 1 minus x and a over 1 plus x squared into the common denominator, but keeping them as separate fractions, I've done that all in one step. If that's a problem for you, you need to go back to the beginnings of C3 and go back over algebraic manipulation, algebraic fractions and things like that. Okay, so now we have two kind of comparable fractions here. We've got the same denominator on both expressions, but we've got these unknown a and b that we're not quite sure what we're doing with at this point. But that's useful, okay? So what we know is that 5 minus x plus 2x squared is equal to a lots of, we're not quite sure what that is yet, 1 plus x squared, and then b lots of 1 minus x. So I'm going to expand out this blue side now. So I've got a times 1, plus a lots of x squared, plus b minus b lots of x. And that I'm still comparing to 5 minus x plus 2x squared. Okay, now I can compare coefficients. So let's have a look at the x squared in the black. There are 2 lots of it. Have I got any x squares on the other side? Well, yeah, I've got a lots of x squared. So I now know that 2 must be a. What about b's? X's rather. Well, next I've got minus x on the black side, and actually the only x I've got on this side is minus b. So I've got minus x, or rather minus 1, because we don't want to include the x anymore. Minus 1 is equal to minus b, which implies that b must equal 1. Now hopefully, well, it's not looking promising, a plus b is what we've got left. And that should equal 5. But a plus b doesn't equal 5. Why is that? At the moment, 2 plus 1 is 3. Okay, just change the question. Change that to a 3. Makes much more sense. So we've now got a 3 there. A plus B is 3. 2 plus 1 is 3. So we knew that we've got the right values of A and B. So our partial fractions must be 2 over 1 minus x plus 1 over 1 plus x squared. In this example, the order of our numerator is bigger than the order of our denominator, that 3 is bigger than the 2. So actually the first step we're going to have to do is long division, long algebraic division, to get rid, or to divide that denominator into that numerator to get some coefficient out. So we are dividing x squared minus 9 into x cubed plus x squared minus 9x minus 3. So, x squared into x cubed gives us x. So taking x cubed minus 9x off the expression. So that disappears. Minus times a minus is a plus. Minus 9 plus 9x is that. So we're left with x squared, because that's x squared minus 0 in there, and minus 3. So I don't think we can divide that in, although x squared plus x squared gives us 1. So we're going to take away an x squared minus 9. That's nothing there. And then minus plus times a minus is plus, so minus 3 plus 9 is 6. So we have got x plus 1 plus 6 over x squared minus 9. And now we can do partial fractions on this expression here. So that one, well, I don't think I really like that quadratic factor there. I think it'd actually be quite nice to split that into the difference of two squares. So we've got 6 over x minus 3, x plus 3. So this is our expression for our quadratic, our partial fraction. So we know we want to write that as something over x minus 3 plus something else over x plus 3. We're splitting that fraction apart. Okay, well imagine we're not doing that for a minute, we're actually putting them back together. We've got x minus 3, x plus 3 is a common denominator, so a has been multiplied by x plus 3, and b has been multiplied by x minus 3, and that's equal to 6 over x minus 3, x plus 3. Okay, so 6 is equal to ax plus 3a plus bx minus 3b. Okay, on this side of the equation I've got no x's. So 0 is equal to a plus b, coefficients in front of x. But in terms of the numbers, I've got 6 on this side and I've got 3a on this side minus 3b. Okay, so if a plus b is 0, then a is minus b, or b is minus a. So in this equation then, 6 is equal to minus 3b minus another 3b. So 6 is equal to minus 6b, which implies that b must equal minus 1, so a is 1. So our complete expression must be our x plus 1 and then plus 1 over x minus 3, so our a over x minus 3, plus minus 1 over x plus 3. And of course we can neaten that up, so that is x plus 1 plus 1 over x minus 3 minus 1 over x plus 3. And that's it. That is partial fractions. That will be so useful, so make sure you can do that skill really quickly.